Well, good morning, everyone. Today I'm going to be going through the Unit 1, Lesson 14 practice problems. Right? So we'll just go ahead and get started on these. Number 1, it says the number of letters received in the mail over the past week is recorded. So you got a 2, a 3, a 5, a 5, a 5, and then a 15. Right, so as you can see here, we've got a pretty tightly compacted little group of numbers, and then 15, which is like 3 times higher than the next neighbor to it. So that one is almost like sticks out like a sore thumb. So which value appears to be an outlier? I'll say 15. Number 2, Elena collects 112 specimens of beetle and records their lengths for an ecology research project. When she returns to the laboratory, Elena finds that she has incorrectly recorded one of the lengths of the beetles as 122 centimeters, which is about 4 feet, which is an incredibly huge beetle. What should she do with the number 122 centimeters when she analyzes the data? Well, the answer that we've come up with is she should remove the outlier because it will affect the rest of the data, and that's very true. I mean, you're talking a beetle should be like a 1, maybe 3 centimeters long. Are you talking 112? Yeah, it's going to really screw up all of your indications there. So that one really needs to be removed. On number 3. May took a survey of students in her class to find out how many hours they spend reading each week. Here are some of the summary statistics for the data that May gathered. So you have a mean of 8.5. Standard deviation of 5.3, a median of 7, Q1 of 1.5, and a Q3 of 11 hours. So you can see that the mean and the median have been separated here, and where the median is at 7, the mean is at 8.5, so it's actually shifted everything kind of to the right. And you can kind of see that too when you look at this thing. Here's Q1 at 5 hours, and then this thing, so 7's pretty close to that. And then you go all the way to Q3, you're at 11 hours. All right, so this is a massive shift there. And that standard deviation is rather high when you consider the fact that your mean is 8.5 and your standard deviation is 5.3. That's a pretty big, rather substantial size on your standard deviation. And letter A says, give an example of a number of hours larger than the median that would be considered an outlier. Well, to be considered an outlier, and it's on the hours larger, you're talking on the right side, on the Q3 side. So what we're going to do is we're going to find the IQR on this thing. So we just take these two numbers and subtract them. You find out that they're 6. Multiply by 1.5, and that's 9. And then you take your Q3, you add 9, so it's 11 plus 9, which is 20. So pretty much any number above 20 is going to be considered an outlier in this instance. All right. And letter B, are there any outliers below the median? All right, so if you consider that, we have the same IQR going on here with the 1 times 1.5 equals 9. And when you take Q1, which is right up here, and you subtract off 9, well, now you get to be a negative number. All right, and pretty much the data has to stop at 0. So there's no way that you could possibly get an outlier on the lower side, on the left-hand side of this thing. All right, so no possible because there. The end of the outliers is at -4. It'd be impossible. Number 4, the box plot shows the statistics for the weight in pounds of some dogs. Now you'll see here that we have a nice little compacted little box here. So your Q1 is right about 35. Your Q3 is right here at about 55. So if you want to answer the question about outliers, we'll just take the IQR, all right, which is going to be 55 minus 35. So you get that to be 20. And you multiply by 1.5 and you have 30. So if you take 55 and you add 30 to it, you're up to 85. So yeah, you got some outliers over here. That's definite. And then you take the 35 here and you subtract 30, that's down to 5. So no outliers over here. All right, so not here, but definitely here. And you kind of see how we've annotated that 1.5, very similar to what you have in the book. Right? So one outlier of 95, which is the maximum weight. All right, so we do have some outliers here, but not on the lower end of the scale. Next page, number 5. The mean exam score for the first group of 20 examinees applied for a security job is 35.3, standard deviation of 3.6. The mean exam score for the second group of 20 examinees is 34.1 with a standard deviation of 0.5. So you'll notice here you've got 35.3 versus 34.1, standard deviation of 3.6 versus a standard deviation of 0.5. So this one is a lot more tightly compacted, a lot more variability here. That standard deviation is high. Right? So this is use the mean and the standard deviation to compare the score groups. Well, most of the scores of the first group are between these two numbers here. All right, so you'll take your standard deviation of 3.6, you'll add it to that and subtract it from that, and that'll give you your 68% of what would be contained there. The second group, very tightly compact. You're talking 34.1, and when you add and subtract the standard deviation, you get between 33.6 and 34.6. So very tightly compacted. I mean, you're talking a spread here of just 1. Here the spread, you're talking like close to 7. All right. And letter B, the minimum score required to get into the in-person interview is 33. Which group do you think has more people to get into the interview? Well, group 2, because their tightly compacted amount is above that. I mean, 68% is above 33. Right. So you have this one's going to have a vast majority of people going there. And this, not so much. They're going to have, of that 68%, they're not going to have nearly so much percent-wise going through. So group 2 has most everyone above 33. So group 2 would be a better choice. And number 6 and 7. A group of pennies made in 2018 are weighed. The mean is approximately 2.5 grams with a standard deviation of 0.02 grams. So very low standard deviation. Interpret the mean and the standard deviation in terms of this context. Okay? So it says, for answer, the typical penny weight is 2.5 grams, and the weight does not vary very much because of the standard deviation is very low. So if you look at this number, 0.02 versus 2.5, I mean, that's less than 1% of what's variance. So that's a really tight tolerance. Not very much variation at all. Number 7, the values that represent expected number of paintings a person will produce over the next 10 days. So we got 0, 0, 0, 1, 1, 1, 2, 2, 3, and then 5. What's the mean and the standard deviation of this data? Well, the mean, you can go through and you can do the mathematics of it. You should get a total mean of 1.5. And you can put this number into a Google Sheet and it'll do the standard deviation for you. And you should be getting about a 1.58. All right. The artist is not pleased with these statistics. If the 5 is increased to a larger value, how does this impact the median, the mean, and the standard deviation? Well, it's going to increase the mean, obviously, because that value is going to be computed in to find the mean. So it's going to raise it. And it's going to, because of that, it's going to also increase the variability, thus the standard deviation. Now it says here, and I quote, if the 5 is increased to a larger value. So we're not going to take 5 and add another number to it. We're going to take the 5 out and put another bigger, higher number in there. All right. So we didn't change the number. So the median is going to stay the same. All right. The median is going to stay the same. You have the same number of characters or data plots. So that's not going to change at all. All right. So the median stays the same, but it's going to increase the mean and the standard deviation. Number 8. List the 4 dot plots in order of variability from least to greatest. So the least amount of variation is almost easy to figure out. That one has the least amount of variation. In fact, it has no variation. This thing is not going to vary at all. And now you kind of have to compare these other ones. It's like, which one has the least amount of variability, which ones has the most. All right. Well, the least is going to be B, right there. All right. And then after that, you got to figure out how much this spread here. Well, you go from 29 to 32, so you got a variability of, like, let's say 3 here. Now the variability here, this one, 23 to 29, you got a variability of about 6. And then you go up here, and the variability stretches between 10 and 22. So that's the least amount of variability. And then the next one's going to be delta, has a little bit more. Charlie's going to have a little bit more. And then the greatest amount of variability is going to be A. So your solution set for this thing is going to be the least is going to be B, and then delta, and then Charlie, and then the greatest is going to be alpha. And that's all that we have for the practice problems. Thank you.